Okay, so before we look at this proof by induction inequality type, it's worth going over what the factorial notation means. So this exclamation mark, when you see something like 4 exclamation mark, that's 4 factorial, we call it, and that's 4 times 3 times 2 times 1. So you take the number that's before the factorial sign, and then you multiply by every number, natural number, back as far as the number 1. So 4 by 3 by 2 by 1, that's the number 24. If I had 7 factorial, well, that would be 7 by 6 by 5 by 4 by 3 by 2 by 1. So it's just a way of writing a number being multiplied by natural numbers all the way back to 1. It's just a shortcut, and there's a button on the calculator if you wanted to find out what 7 factorial is. You can just put 7 and the exclamation mark. If I had something like n factorial, that's not something obviously we're going to be able to work out, so we don't know what this number n is, but I do know that it's n multiplied by the number before it, which is n minus 1, multiplied by the number before that, which is n minus 2, all the way back until we get down to multiply by 2 and multiply by 1. If I had n plus 1 factorial, well, that would start at the number n plus 1, and I would multiply by the number before n plus 1, which is the number n. I'd multiply by the number before that, which is n minus 1, and I'd multiply all the way back until I'm at 3 by 2 by 1. So that's what the notation means. It's just a way of writing numbers being multiplied by one number less all the way back to 1. So let's go ahead and do this proof by induction question, given that we now know what the factorial notation means. With these types, we first have a look at what is the condition. Well, the condition is that n is a natural number, so we're going to show that this is true. So show that this is true for n equals 1. So on the left hand side, I'm going to put in 1 plus 1, and then I have the factorial symbol. That should be greater than or equal to 2 to the power of 1. 1 and 1 is 2, so 2 factorial should be greater than or equal to 2. 2 factorial is 2 times 1, and 2 times 1 is greater than or equal to 2 because 2 times 1 is 2, and 2 is equal to 2. So the condition is met or true for n equals 1. We're going to assume that it's true for n equals k, so assume true for n equals k, which just means write the inequality as it is, except replace the n's with k's. So k plus 1 factorial is greater than or equal to 2 to the power of k. And we leave that, we'll return to it in a minute. And then we want to prove true for n equals k plus 1. So we're going to go one step further. So where we have a k plus 1 squared, that's going to be a k plus 1 plus 1. Replacing the k with a k plus 1. Factorial is greater than or equal to 2 to the power of k plus 1. We're going to tidy up the left hand side. So k plus 2 factorial is greater than or equal to 2 to the power of k plus 1. So this is what I'm trying to prove. And so I'm going to use a bit of color. I'm going to say that this is A and this is C. I'm trying to prove that A is bigger than C. I'm going to return to the assumption, which I know is true, and I'm going to write it down again. I'm going to write down that k plus 1 factorial is greater than or equal to 2 to the power of k. So start with something that we know is true. And the idea is to turn the left-hand side into the left-hand side of what we're trying to prove, this A part, let's call it. Well, if you have k plus 1 factorial and you want to turn that into k plus 2 factorial, well, you'd multiply by k plus 2. Like if you think about it, let's put it in first of all and we'll explain it. So I'm going to multiply the left-hand side by k plus 2. If you multiply the left-hand side of an assumption, if you want to maintain the truth of the inequality, you have to multiply the right-hand side by the same thing, k plus 2 times 2 to the power of k. Now, why did I do this? Why is it that k plus 2 times k plus 1 factorial is actually k plus 2 factorial? So we'll just, let's put this 2k in front here. So why is that true? Well, think about it. If I have the number 6 multiplied by 5 factorial, well, 5 factorial is 5 by 4 by 3 by 2 by 1, and then multiplying by 6, well, that turns it into 6 factorial. So if I have k plus 1 factorial and I multiply it by a number that's 1 bigger than k plus 1, well then it turns it into that number factorial, k plus 2 factorial. Okay, so with that said, what I have now is I have the left-hand side of the assumption. I've adjusted the assumption to multiply both sides by k plus 2. The left-hand side of the assumption, I'm going to say that A, because that's the same as the left-hand side of what I'm trying to prove, is bigger than or equal to, let's call this B. And with an inequality proof, what we're trying to do is we're trying to show that A is bigger than C. We've now shown that A is bigger than B, or bigger than or equal to B. And so if I can show that B is greater than or equal to C, then A will be bigger than or equal to C. So I'm going to write down B. So B is 2 to the power of k on k plus 2. And if I can show that this is greater than or equal to C, so sorry, C is 2 to the power of k plus 1. I'm just going to put in the C. So if I can show that B is bigger than C, I know A is bigger than B, so then A would be bigger than C, and we'll have proved what we're trying to prove. Okay, so if I take this and have a quick look at it, what I'm going to do is on the right hand side, I am going to use the law of indices to change 2 to the power of k plus 1 into 2 to the power of k times 2 to the power of 1. I can see that I have a 2 to the power of k on both sides, so I'm going to divide both sides by 2 to the power of k, and I am left with k plus 2 is greater than or equal to 2. I'm going to subtract 2 from both sides, where I get k is greater than or equal to 0. So B will be bigger than C if k is greater than or equal to 0, but k will always be greater than or equal to 0 because we're only ever going to sub in natural numbers, the first of which is 1. So we know that B is bigger than C, and if B is bigger than C, we can say that A is bigger than C. And the way we can write that is we can have the A first. We know that k plus 2 factorial is greater than or equal to B, which I'm saying is 2 to the power of k on k plus 2. And I also know that this is bigger than or greater than or equal to 2 to the power of k plus 1, the C. Hence, A is obviously bigger than C, which is what I was trying to prove. Remember that to finish these questions, we need to write down the statement. We have proved true, we have shown true, true for n equals 1 if the proposition is true for n equals k, then it is true for n equals k plus 1, therefore true for all natural numbers n element of n. So you have to have that statement at the end just to get your full marks in your question. But a nice example of an inequality, which is generally the most tricky of the types of proof by induction, but one that also had this use of factorial notation.